Today I am going to give you the basic glimpse of class 10th trigonometry. Trigonometry, as we know, is made up of three Greek words, that is tri, gon and metron, which is three sides measurement. And we know that three-sided figure is a triangle. For 10th class purpose, we take only right angle triangle into consideration, and we apply trigonometric ratios on acute angles only. Now, let us see a right angle triangle ABC, which is right angled at B. Suppose this angle is theta. So this A will be 90 minus theta. In right angle triangle, we know that a hypotenuse is the longest side. So the longest side is fixed, but other two sides can be changed according to the concerned angle. For example, if I am taking this angle theta, then the sides over which it is forming is known as the base, and the side opposite to it will be known as perpendicular. But if I am taking this 90 minus theta into consideration, that then the sides over which it is forming is AB, and the side opposite to it will be the perpendicular. So these two sides are interchanged and the hypotenuse is always same. Now trigonometry is studied by the help of trigonometric ratios. Trigonometric ratios are nothing but the relationship between the sides and the angle of a right angle triangle. Let us see how many trigonometric ratios are given. They are in total they are 6: sine, cos, tan, cosec, sec and cot. So these are the trigonometric functions. So these will be applied on some variable, and here I am taking variable as theta. So sine of any angle theta can be defined as perpendicular upon hypotenuse. Here perpendicular is AB and hypotenuse is AC. In cos theta can be defined as base upon hypotenuse. So base is BC and hypotenuse is AC. BC upon AC. And tan theta can be defined as perpendicular upon base. Perpendicular is AB and base is BC. Now the cosec theta can be given as 1 upon sin theta. So it will be AC upon AB. And sec theta can be given as 1 upon cos theta. So it will be AC upon BC. And cot theta is given as 1 upon tan theta. So it will be BC upon AB. Now let us calculate the sine of this 90 minus theta. Sine of 90 minus theta. Here this 90 minus theta is the complement of theta. So 90 for this angle 90 minus theta, perpendicular is BC and hypotenuse is same. So perpendicular is BC and hypotenuse is AC. But this BC upon AC is nothing but cos theta. So the complement of sine 90 minus theta will give you cos theta. In similar way, cos 90 minus theta will give you sin theta. Now let us calculate the value of trigonometric ratios for some specific angle. This is 45, let us say, and this angle this side is A, suppose, and this side is also A. Now first we calculate hypotenuse using Pythagoras theorem, which states that hypotenuse square is equal to perpendicular square plus base square. Here perpendicular is A and base is also A. So hypotenuse AC will be 2A square. Now let us take the square root 2A square, which will give you root 2A. Now sine 45 is perpendicular upon hypotenuse. So perpendicular is A and hypotenuse is root 2A. So it will be 1 upon root 2. And cos 45 can also be calculated as base upon hypotenuse. Base is A and hypotenuse is root 2A. So it will be 1 upon root 2 also. And tan 45 can also be calculated as perpendicular upon base, which is A upon A and 1. Now let us calculate the table, or I should say let us see the table for some specific angle. 0, 0, 30, 45, 60 and 90. First I will tell you how to devise this table. First we will write the number from 0 to 4. 0, 1, 2, 3 and 4. Now let us divide these numbers by 4. And take the square root of this table. So this will be 0, this will be 1 upon 2, this is 1 upon root 2, and this is root 3 upon 2, and this is 1. So sine, let us say this angle is A. So sine A is sine 0 is 0, 30 is 1 by 2, and this is 1 by root 2, and this is root 3 by 2, and this is 1. In similar way, you can calculate cos. You will just reverse this table. So 1 root 3 by 2, 1 by root 2, 1 by 2, and 0. For tan can be calculated at sine upon cos. So sine upon cos can be calculated. 0 upon 1 is 0, and this will become 1 upon root 3. This is 1, and this is root 3, and this is not defined. If we get 0 in the denominator, then this number is not defined. Similarly, we can calculate cosec, sec and cot with the help of 1 upon sine, 1 upon cos, and 1 upon tan. So let us just put a thought that sine, the minimum value of sine is for 0, and this is 0, and the maximum value is for 90, and the cos is just reverse. So the value of sine and cos are just oscillating between 0 and 1. Now let us see some trigonometric identities. Now let us again take a right angle triangle ABC. Let us first write Pythagoras theorem, which is AC square is equal to AB square plus BC square. Now let us divide this whole equation by AC square. So, and let us say this angle is theta. AB upon AC whole square plus BC upon AC whole square. So this is 1, and AB upon AC is nothing, perpendicular upon hypotenuse, so it will be sine theta. So sine square theta, and this base upon hypotenuse BC upon AC is cos theta. So we get first trigonometric identity as sine square theta plus cos square theta is equal to 1. In similar manner, we can calculate other two identities by dividing one time by 1 AB square and other by BC square. So we can get other two trigonometric identities. These are in total 3 identities.